Alright, hi Year 11, this is Mr. Lim here again, and this is our fourth video on acid reactions. Oh my goodness, I haven't got this title right. Okay, well, this is our fourth video on acid reactions, not chemical bonding, and so let's get started. Alright, so what are we doing? We're doing acid reactions. Okay, so the idea is that acids react in a predictable way, okay, so we can predict they're going to form when they react with other chemicals. All right, so all these reactions that we are going to deal with produce what's known as a salt. A salt is produced from the anion or the negative ion of the acid and the cation or the positive ion from the other chemical. Okay, so the negative part of the acid and the positive part of the other chemical, that is what's going to form this salt. Okay. The reaction should be written in ionic form where possible. All right, so information about the state should be included and spectator ions removed. We'll deal with that later, and in general, all acids will be in solution form for now. All right, and then we'll deal with different forms later on in year 12. All right, so these are a couple of the rules. So let's get started and we'll go walk through some of these ideas. This is a bit of a checklist of things to do when you write out these acid reactions. So let's get started. All right, so here is... All right, here is the first one we're going to do. All right, so on this side, we've got our checklist. On this side, we've got the information that we need for precipitations, for colors of stuff, and for metal reactions, we'll need this page, which is on the back of your data sheet. So this is all the data sheet stuff, and this is the stuff you have to memorize. So let's get started. Okay, so number one, state of the reactant, okay, the other reactant. So this one here, sodium hydroxide solution, this is a solution, so we know that the sodium and the hydroxide will be in aqueous form, okay. Write the other reactant, we did that. Check the strength of the acid, so we've got hydrochloric acid, so we should hopefully remember that that is a strong acid, so we say that it totally ionizes. Okay, so it totally breaks apart, and so therefore I write the acid. So there's my two bits, and I've got to write in my states. Okay, right, check for reactivity in metals, don't need to do that. So now we're going to write out the salt that is formed. So remember, the salt that is formed comes from the negative ion of the acid and the positive ion from the other substance. So that means it's the Na and Cl. So that salt is Na plus Cl minus. That's the salt that is formed. All right, now we're going to check the salt for precipitation. So sodium chloride, we check over here. The chlorides are soluble, so therefore they stay as aqueous, they stay split apart. We're checking the salt for color, so we say, okay, well, what color is sodium chloride? It's not here, this is at the top of the page, and then we check over here. The sodium is not there, the chloride is not there, so therefore it is colorless. Okay, so this is colorless. Then we're going to write out the other products. So for the reaction between an acid and a hydroxide or oxide solution, we're going to look over here. All right, so acids with hydroxides and oxides will produce water and salt. So water and salt. So we've already written out the salt, we just now need to write out the water. So here we go to write out the water. Okay, H2O, that's going to be in liquid form. Okay, we've done that. So now what's next? So we've written out the other product. Check for spectator ions. Okay, so spectator ions. We should see that the sodium is a spectator ion because it's on both sides of the arrow. This is also a spectator ion, so we're going to get rid of those. Okay, so we did that. Now what? Check that all the states are stated. Okay, we put states on everything, yep. And then write the observations for reactants and observations for the products. Okay, so if we notice here that this combination here, the sodium hydroxide, has no colors, so therefore this is colorless solution. All acids are solutions, and this one here is colorless as well because there's nothing that's got color. And this is also a colorless solution, so you're actually going to have a colorless solution added to another colorless solution to form a colorless solution, which means that you're not going to actually see anything. So this is going to be no visible reaction. Okay, so even though there is a reaction occurring, there's going to be no visible reaction because there's going to be two colorless solutions combined. Two colorless solutions combined to form a colorless solution. Okay, so that's the first example. All right, we have to have the information from the data sheet and the checklist in our heads to work this all out. Okay, so let's move on to the next example. Okay, so we've got the nitric acid and barium hydroxide powder. Okay, so nitric acid, barium hydroxide powder. So first thing, check the state of the other reactant. Okay, so it's barium hydroxide powder, which means that it is a solid. So we're going to write out the other reactant, barium hydroxide, and hopefully you've remembered that the hydroxide is a -1, the barium is a +2, and so therefore that one's going to be BaOH2 in brackets. Right, next, we did the other reactant. Okay, so check the strength of the acid. So nitric acid is a strong acid, and so therefore we can write it as split apart. So H plus AQ plus NO3 minus AQ. Right, so we did that. Write the acid. Check for reactivity metals. Don't need to do that. Write out the salt. Okay, so the salt is made from the positive part of the other substance and the negative part of the acid. So it's going to be barium nitrate. Okay, so I'm going to write this out as Ba2 plus AQ and nitrate AQ. Okay, so you write those out as separate and then you check if they precipitate. Alternatively, you can check if they precipitate, but you got to know what the salt is. But we're going to check it for precipitation. So barium nitrate, check over here in your data sheet, nitrates, all soluble. So it's going to be like this, barium nitrate there. Okay, check the salt for colors. Okay, well, barium nitrate not over here, barium's not over here, nitrate's not over here. This is on your data sheet again, and so therefore this is colorless there. Right, so write out the other products. Okay, so remember acid plus hydroxide, the other product is water. So we're going to write out the water. Okay, then check for spectator ions. Okay, so is the barium a spectator ion? No, because it went from solid to aqueous, so that is not a spectator ion. However, this nitrate is a spectator ion, so I get rid of those two. Okay, and so therefore then all states are stated. Yep, did that. Okay, and then you can write the observations if necessary. So what color is this powder? Remember, the solids take the color of the component ions unless it's in that particular table, this table here, which is at the top of the page. Right, so it takes its color of the component ions. Since barium and hydroxide have no colors, it is a white powder added to a colorless solution. Remember, all acids are colorless solutions at the moment, to form a colorless solution, which is the water, and actually because barium is not any colored, and the white solid, the white powder dissolves. Okay, so it's important to say that the white powder is no longer there, okay, because it has dissolved into solution. All right, so then that's the observations. Okay, so let's move on to the next one. Okay, so we're doing phosphoric acid and nickel 2 oxide chips. Okay, so phosphoric acid, nickel 2 oxide chips. Check the state of the other reactants. Nickel 2 oxide chips. Chips is another way of saying solid. Okay, so it's nickel 2 oxide, so it's NiO solid. All right, nickel 2 is 2 plus, oxide is 2 minus, so that's that. Okay, write the other reactant, we did that. Check the strength of the acid. Okay, so this is phosphoric acid, and hopefully you'll remember that that is a weak acid. And if you remember weak acids, we write all together. Okay, so we don't split them apart. Okay, so we did that. Check of the reactivity of metals, doesn't count for this one. Write out the salt. Okay, so what is the salt going to be here? It's going to be the positive part of the other and the negative part of the acid. So this is going to be nickel phosphate. Now, it's nickel 2 plus, and the phosphate is a -3. So this is going to be nickel 3 phosphate 2. Okay, on a side note, this is why it's so important to memorize these ions, because if you have these in your brain, it doesn't take a lot of your working memory for you to put them together, all right, and therefore you can move on to the harder stuff. Okay, so nickel 3 phosphate, I should write them as separate. Oops. Nickel 2 plus AQ and phosphate 3 minus AQ. Okay, because we should stay consistent. We're going to do this until we check for precipitation. Okay, so I wrote the salt out. We're going to check for precipitation. So phosphates, well, most of them are insoluble. Is nickel an exception? No, it is not. So this is wrong. I actually need to put that into a solid. So that's why I go back to what I wrote before, nickel 3 phosphate 2 solid, right? So there should be an arrow here somewhere. Okay, so that's the salt. Okay, write out the other product. We should remember that it is water. Okay, and then check for spectator ions. So there are no spectator ions here. All of the substances have gone from one state to another or from one substance to another, so there's no spectator ions. All right, check that I've put in all my states. Yep, write observations for reactions. Okay, so what color is this nickel oxide substance? Okay, so nickel oxide, not here. So we check the colors of its component ions. Nickel is a green ion. Oxide is no color, so therefore this is a green solid. Okay, so green solid, or green chips, or green solid, added to a colorless solution, which is your acid, to form another green solid, because the nickel phosphate is green again, in a colorless solution. Okie dokie. All right, so that's that one there. Next, in year 12, you will have to take into account which one is in excess, and if one of them is in excess, then it will change the way that this reaction goes, but we'll deal with that in year 12. Let's move on. Okay, so this is the second type of reaction. Okay, we dealt with acids and hydroxides and oxides. Now we're dealing with acids and carbonates and hydrogen carbonates. They will produce water, carbon dioxide, and the salt. So remember, salt is always there. Water and carbon dioxide are the two new other products. Carbon dioxide is a colorless, odorless gas. Okay, so let's have a look at this first example. Okay, so sulfuric acid and calcium carbonate powder. Okay, so check the state of the other reactant. Our first thing on a checklist, calcium carbonate powder. Calcium carbonate powder is a solid, so calcium carbonate solid plus sulfuric acid. Sulfuric acid is a strong acid, so we're just going to write H plus AQ, and sulfate 2 minus AQ. Oh yeah, you should be balancing all these equations. I don't think I balanced the last couple of equations, but you should go back and balance them as well, right? So let's make sure we don't forget on this one. Okay, so I wrote the acid, check for the reactivity metal, doesn't count, write out the salt. Okay, so this is going to be calcium sulfate. We're going to take the positive from this part and the negative from this part, calcium sulfate. We're going to check if it's soluble or not, and it is slightly soluble, which means that it's not really that soluble, so therefore we're going to say that it's going to form a solid. Okay, so calcium sulfate, solid. All right, that slightly soluble is actually related to the concentration that it is, but we're going to assume that it's a reasonably high concentration, so it's going to be a solid there. All right, and then so we wrote the salt. We checked the salt for precipitation. We checked the salt for color. Calcium is not colored. Sulfate is not colored. Calcium sulfate doesn't have a color, right? So therefore, I can write out the other products now. Okay, so remember, when you add an acid to a carbonate, it's going to form carbon dioxide gas and water. Okay, and therefore now I can check for spectator ions. Well, nothing is a spectator ion because the calcium went from calcium carbonate to calcium sulfate. Sulfate went from aqueous to not aqueous. Right, hydrogen's adding to the water, carbon dioxide's coming from there to there, so nothing here is a spectator ion. Okay, check them, all my states are there, yep. All right, write observations for this. Okay, so what color is the calcium carbonate? It's a white powder. White powder added to clear, I don't need clear, I just need colorless solution. Colorless solution to form another white powder a colorless liquid, colorless solution, and a colorless, odorless gas. And that is the carbon dioxide. Okay, all right, let's have another go. Okay, we're going to do ethanoic acid and sodium carbonate solution. Okay, so ethanoic acid and sodium carbonate. Right. Let's do this one. Check state of the other solution of a reactant. It's a solution, so I can write them out separately. Sodium AQ carbonate AQ. Right. Check the strength of the acid. Ethanoic acid is a weak acid, so therefore it is CH3COOHAQ. Right. Right, the acid did that. Check the reactivity of metals. Doesn't need to do that. Write out the salt. Okay, so it's going to be sodium ethanoate. Okay, so this one here is what's known as a monoprotic acid. It's only going to give off this particular hydrogen. So this is going to be the ethanoate ion that is formed. Hopefully you've memorized that. And the sodium there. So sodium ethanoate, we write that out separately until we check whether it is precipitated. But I know that all the ethanoates do not precipitate, so it stays separated like that. Okay, check the salt for color. Sodium's not colored. Ethanoate's not colored, so they have no colors. All right, write out the other products formed. So that's the carbon dioxide and the water. No, I haven't balanced the equations. Oh, didn't balance the last one either. All right, so make sure that there's balance. Maybe add that to your checklist. All right. Check for spectator ions. Okay, well, the sodium's there. That one is a spectator ion, so it's just those left over. Right, and then observations. So, 2 colorless solutions, because both of these are colorless solutions. Nah. 2 colorless solutions added to form a colorless odorless gas. That's the carbon dioxide. Oops. In a colorless solution. Okay, let's move on. Okay, the last one is phosphoric acid and copper hydrogen carbonate powder. I want you to have a go at this one yourself, and then the answer will magically appear. Ta-da! That's the answers you should have gotten, so hopefully you got that right, and then you can go practice that in class. Okay, let's go to the next one. All right, so now we're on to the last type of reaction we're going to need to learn. Acids and reactive metals will produce hydrogen gas and a salt. Hydrogen gas is a colorless, odorless gas, so remember it's a salt, and the hydrogen gas is produced as the other product. We're going to use the back of the data sheet to find the standard reduction potential table. With metals which have an E volts value less than 0 are reactive. All right, so that's what we need. That's what we mean by a reactive metal. And the metal is the cation in the salt. So the metal itself is the positive part of that other substance. Okay, so let's have a look. This is the standard reduction potential table. All right, this is found at the back of your data sheet. What we're saying is that any metals which are found as a negative value are reactive metals. So here you have lead, tin, nickel, cobalt, chromium, zinc, sodium, calcium, strontium. Those are all reactive metals. Things that are not reactive metals are copper, silver, and gold. All right, so anything in there's a negative value for their E volts here. All right, so those are the reactive metals. So let's have a look at this one here. Okay, so hydrochloric acid and magnesium metal. So check the state of the other reactant, magnesium metal. That just means it's solid, so that's Mg solid. Okay, check the strength of the acid. Hydrochloric acid is a strong acid, so we're just writing H plus Cl minus. Okay. All right, check the strength of the acid. Check the reactivity of the metal. Okay, so we check here. The metal is magnesium, and magnesium is here. So therefore, it is a negative value, so therefore it will react. Okay, so let's go back. It will react. So if it will react, we can go start with the reaction. I'm going to write out the salt. So the salt is going to be the metal and the the metal as a positive ion, and the negative part, which is the Cl minus. Okay, right, we're checking that for precipitation. So any chlorides, only the silver chloride and the lead chloride. So therefore that is going to be soluble, so it's going to stay that way. And you're going to form H2 gas, hydrogen gas. Okay, so those hydrogens here combine and then form one of those. All right, so let's look for spectator ions. Spectator ions. Is this a spectator ion? No, because it changed state and it changed charge as well. Is this a spectator ion? Yes, it is. Okay, so I'm going to get rid of those. All right, and the hydrogen isn't because it went from H plus to H2. All right, you should balance this equation by putting a 2 here, right? And then now it's balanced. Okay, and check all states stated. Yep, we did that. And observations. So A, now remember all metals are gray colored, a gray solid. And you can say it's shiny if you want. Added to a colorless solution to form a colorless solution because the magnesium and the chloride are both colorless, and a colorless odorless gas. Gray solid dissolves. You should always say if the gray solid dissolves, if the solid at the beginning goes away. All right, so that's that one here. Let's go look at the next one. Okay, so let's have a look. Next, sulfuric acid and copper metal. Okay, so let's have a look. Check the state of the other reactant, copper metal. So that's Cu solid. Right, the other reactant, check the strength of the acid, that's sulfuric acid, so it's H plus and SO4 2 minus, AQ and AQ. All right. Check for the reactivity of metals. Okay, so copper, right, we're looking over here. Copper is in fact here, and it's a positive value. So since it's a positive value, it's not going to react, okay, because it's not a reactive metal. So since it doesn't react, it's going to have no reaction. Don't have to continue anymore. Okay, you can still write observations. The copper is a salmon pink. Okay, so I didn't include the table, but a salmon pink solid added to clear colorless solution. No reaction occurs. Okay, all right, so you got to check that one as well. Let's go for the last one. Okay, nitric acid and iron metal. All right, so this is a bit tricky here because in here, you got to find the iron metal. Now, iron is actually in a couple of places, right? So iron is here, but that's not iron metal because that's Fe3+, that's Fe2+. Okay, so we need iron metal and it's over here. And so that is a negative value, so that will react. Okay, so have a go at this particular reaction and the answer will magically appear in a moment. And here's that final answer. All right, so have a go, practice this in class, and we'll see how we go. This is just the first part of all of our reactions, and we'll learn much more about them next year as well. Adios.